معك المدير العام لمجلس صناعات الطاقة النظيفة. موضوع اليوم حيكون الاقتصاد الدائري ومستقبل الطاقة. Good morning, everyone, and welcome to the fourth day of the Arab Sustainability and Environment Week, which is co-organized by the Environmental Center for Arab Towns and the Clean Energy Business Council. My name is Bushra Barakat, and I'm the Managing Director of the Clean Energy Business Council. Today, the theme of the event will be Circular Economy and the Future of Energy. المتحدث الأول معنا اليوم هو السيد راج كومار براساد، رئيس قسم الاستدامة في الشرق الأوسط وأفريقيا في شركة BSI، وعنوان المحاضرة حيكون استراتيجيات الاقتصاد الدائري. The first speaker with us today is Mr. Raj Kumar Prasad, the Head of Sustainability in BSI, the British Standard Institute in Middle East and Africa. And the title of his presentation will be Circular Economy Strategies. Mr. Raj, thank you again for being with us. If you want to share your screen.
Yes, I will now share.
Thank you, Mr. Raj. The floor is yours.
Thank you so much. And it's a matter of great pride and pleasure to be part of this platform and getting an opportunity to speak about circular economy strategies on behalf of BSI Middle East and Africa. So that's a really something great opportunity. As I mentioned that, it's a really time that we all need to come closer to have a discuss from various angles, such kind of need of the time that we have come closer. So thank you very much. I'll proceed for my various slides. But before I go to the next slides, I would like to just inform the viewers that my slides are arranged in terms of very few slides, which will talk about background and the concept about the circular economy. And then my topic, which I'll be focusing on the strategies that is based on circular economy. In fact, circular economy concept, it's not a new concept. It existed long back, in fact, and but it used to be in a different name. For example, if we go maybe 30, 40 years back, some kind of terminology came up in existence, a spaceman economy. Then further, the terminology got floated, limits to growth and a steady state economy and a performance economy, industrial ecology, cradle to cradle concept. All these concepts, they were basically more or less, they were talking about basically circularity. They were basically meaning about the circularity, how to make our living style sustainable. And but currently, what happened? This circular economy concept came into limelight, and it's basically a regenerative economic system. And normally we have a kind of a scenario that we are in the society, which obviously gives us most of a kind of a living style that we are taking, making, and disposing it. And now we need a basically shift. When we look at from the sustainability point of view, we need a shift from take, make, and dispose. What we need to make a shift is basically we need to go towards take, make, use, and regenerate. Instead of disposing, what we are trying to shift towards now is basically take, make, and use, and regenerate. So this is a kind of resource model, which is different from take, make, and dispose. And this new model is very much aligned with sustainable development. And essentially, this model, which is a circular economy model, this is helping us or aiming to redesign the production and the consumption system. So that's how I can put it as a circular economy, though there are many other definitions. But essentially, all those definitions of circular economy, they will be meaning exactly similar to this. I mean, we are talking about redesigning the production and consumption pattern within our society framework. But recently, as I mentioned that, circular economy existed in a different terminology long back, but now it has become a very recent development again, and it got a due focus and attention. And this concept renewed recently, and China was very aggressive, in fact, in terms of implementing this circular economy because of obvious reason that that they have a high population, and then of course when there is a such kind of pressure from different point of view, from environment or from resource point of view, then circular economy, as we understood that it's basically a regenerative model, a resource model, then it makes a lot of sense. So it got early adoption in China, and currently it has got a lot of attention in Europe as well, and a lot of progress is happening. But if we go into much into details, how this development and work that is towards circular economy is happening, it's largely scope documents and initiatives from government and non-governmental organizations. So if we go much more into details that how this circular economy can be embedded or can be implemented by an organization, or can be implemented at a micro level or even medium level of organizations or large level organizations, still we have a lot of questions, in fact, how to do this. And that is what some of the strategies that I'll be trying to share my thoughts on this. So if, as I mentioned, that it is a regenerative resource model, it has basically three main concepts to drive the circular economy. I would say that circular economy can be driven by three pillars, and which can be understood as a design principle, and then waste as a resource principle or model, or we can call it a business model. So if you see in the center of this circle, we are talking about a retain, and then when we go out, we are now getting into different direction of refit, and then we are talking about a refurbish, and then we are talking about a reuse, and then we are talking about a remanufacture, and then we are talking about a recycle. So when we are trying to retain certain product that has been manufactured, uh, we can try to also retain by certain mechanism. The product goes to the consumer, and it can, in some manner, if we develop, it can also come back. And then the other type that we can do from the product point of view is that refitting into the product once it comes back, or any kind of service provision that can be rebuilt. And if not possible, it can be done to refurbish. Refurbish is another terminology where we can do certain kind of changes within the product system, and then it can become as a new product. And then we have a next one is a reuse. And after reuse, there is a remanufacturing process, because after reuse, the quality of the product, it goes to a level down where it needs remanufacturing. And it's a different concept, that manufacturing, because manufacturing is original taking from the resource. And after remanufacturing, again, after various uses, when the components has lived its life probably to its fullest extent, we can look at from the concept of a recycling as well. So currently, when we are talking about, if you're talking about from the waste management point of view, where normally I'm sure all the respected members here, they must have heard about recycling, and which is basically a waste prevention. But when we are talking about circular economy, we are talking about one step ahead, that is a remanufacturing. We are talking about further one step ahead, reuse. We are talking about further one step ahead, that is refurbish, and so on to the level of refit and retain. Now, the other important pillar that I said, circular economy, is basically design principle. Now, when we are trying to do such kind of work, when retain, refit, refurbish, reuse, remanufacture, and recycle, we need to design, think of design in an innovative manner. It needs a lot of innovation. So there are ways that we can, when we are manufacturing our product, or even at any stage, refitting, refurbish, reuse, or remanufacture, we need to look at from the design perspective how they can be redesigned or designed for adaptability, or we can design to see that no waste is generated, maybe some kind of modularity, or designed for disassembly, that if we are innovative enough, and whatever that product that we are designing, we can make sure that it can be disassembled properly, and then it can go to the extent of either refurbish, reuse, or remanufacture. And then also material selection plays a very, very important role in such kind of designing out scenario. Now, apart from this, having spoken about waste as a resource and a design principle, The business model also helps us out as a third and important pillar of the circular economy, where we can actually look out for a different way of conducting business. Because normally when we have a take make use kind of concept in a business model, then it basically manufacturer gives a product to the user and that's all. But when we are talking about refit, refurbish, reuse, remanufacture, the product has to come back, and different level of refitting or refurbishing or reuse, it has a different level of interaction with society and all of us, so the entire model becomes a different. So business model also needs a revamping kind of scenario, and slowly it can happen, once we see from this. I would like to also mention respected member here, that when we have a such kind of adoption principle of circularity, when we embed it as a resource, and it was actually existed also, and when we were doing locally sourcing naturally organic material and we were manufacturing it, it was quite sustainable. But now actually we have forgotten, because we have become now more international based and a consumer kind of society. But if you see the way the industry fourth revolution or 4.0 that is progressing from a commodity to product or to service economy, we can really see that a time is coming where it will be not a one-off sale. It will be basically continual income stream from selling the service and not the product. So we can really see that how the continuous stream is getting generated from such kind of circular economy system, where we are talking about essentially regenerative resource model. So the business is getting actually very, very positively impacted. And when we are talking about the strategies, essentially we are trying to see that how this circular economy we can implement it with a time-bound manner, and what activities or action plan that we have it. So now, as we know that circular economy is a very value-laden and very broad concept, we need to basically break it down in terms of various action items, and these action items can be defined in a time-bound manner by by many organizations or any organization of any nature, of any size, and those action items, they have to be decided in a time-bound manner, that how it is going to help us to implement a circular economy concept. And there are various approach as far as these action items are concerned. We can look at from the eco-efficiency as a purpose of the organization, that okay, we want to be eco-efficient, or we can also see that we want to be more of a economic value. So when we try to do remanufacture, or when we are talking about refit, or when we are talking about reuse, in those kind of scenario, of course it has a more economic value in fact. And of course, when we talk about from the combining it from the business model point of view, it has a lot of job creation, in fact. And at the same time, of course, when we are trying to see that product is used with so many lives after it's gets produced and it goes back to the system, either from retaining or from rebuilding or from remanufacturing, then of course it has a lot of impact in terms of reducing the emission and of course the corresponding waste. So it has a lot of advantage. In fact, the advantage is a immense. And then of course I'm sure you must have got some indication that it has a lot of improvement in terms of resources security, because if we become truly circular, the resource becomes very, very less as a requirement, and then we become resource secure kind of, or we can say resource resilience kind of scenario that we attain through circular economy. And of course, then when we have a such kind of scenario, then decrease in price volatility and of course in the resources. Here I would like to mention to the respected members that eco-efficiency and we have a eco-effectiveness two concept. When we are talking about eco-efficiency as a purpose, then we are talking about basically minimization of cradle to grave flow of materials. While when we are talking about eco-effectiveness, which is basically a cyclical resource, a cyclical generate model, and which is a basically cradle to cradle metabolism. So whatever material that finally gets wasted through recycling process, it becomes again a resource which can go into the first production system where it was actually manufactured or originally manufactured. So the various approach that we can attain from such kind of strategies, we can make a mix of these bullet points for any organization. And we can see that what are, depending upon the nature of the organization, depending upon the activities of the organization and the business functions, uh, organization can pick up a combination of these approaches for their strategies, and they can, of course, jot it down or make an action item in a time-bound manner to attain circular economy. Uh, I wanted to take through the respected members here about the strategies. When I was talking about what are the action items that we can really look at, so that we can really make our aim of being a circular economy as a reality. So when we think about that, we need to have various functions or various activities. We need to note it down, we need to jot it down, and we need to see that how we can implement them, how we can adopt them, and how we can practice within an organization. So for example, as an example, I have put here down on the left, you can see the material sourcing, and then the design phase, and then the manufacturing, and then of course it can also come to the distribution and sales stage, and then consumption and use, collection and disposal, and remanufacture, recycling, and recovery. I'll go back to now top one, which is a material sourcing. And when we are talking about the material sourcing, few important things that comes to us from circular economy point of view, three areas, which could be a good strategy that, we need to bring diversity in the materials. And also we need to have a cross-sector linkage. And if we want to practice, there are many industries that we can come closer of similar nature, either from the supply chain point of view or from the point of view of, how our material from production point of view or any part of our production system can be synergized with any other industries. So when we are talking about cross-sector linkage, we are talking about essentially not only within our industry, but we can also do a more collaborative approach with other partners, either supply chain or even from the other sectors as well. And in such kind of scenario, if we want to really practice, many standards and practices or guidance documents which are available, which can help really us very well. One of them that I think very important is the transparency-based system that we can adopt, and there are many risk management tools as well, and then regulation-based, which can bring compliance and transparency, and of course we can focus on education as well, which can be converted into as a innovation from the business point of view. Now, again, from material sourcing point of view, other strategy could be energy production and energy autonomy. So when we have energy, when we are having such kind of energy, which we are using it and it is contributing to CO2 emission and global warming and climate change kind of scenario, we need to think creatively. And fortunately, our region is blessed with solar power or solar energy, and we can use as maximum as possible. It's really abundantly available in our region, and we can see that how renewable energy can help us to further bring our circularity. And when we have such kind of renewable energy system in practice, there are products available in the market, and if we practice to ensure the quality of such products, this will help us in getting either producing energy or even energy autonomy. Then we have a green procurement. Now, in supply chain, we can also emphasize that how our supply that is coming, as I mentioned that, long back we were talking of locally resourcing, but now becoming of, because we have become international in nature in all aspects, we are resourcing from anywhere. So when we are talking about a green product, essentially we are talking about, we are looking at the, from supply chain point of view, the material that we are resourcing, that how it can have a minimum impact as far as the environment is concerned. And there are various standards and guidance available again For example, life cycle analysis based comparison either for goods or even for services. So we can look at from that point of view that how such kind of standards can be practiced. I'll go few more for strategy, then I'll go for next slides because I need to see my time as well.
2 minutes left. That's it.
Okay. Then, in fact, we have design for disassembly, recycling that I was mentioned. Then there are again many ways of making our product from the we can adapt it for disassembly and recycling and then reuse and remanufacturing. And I'm sure this information will also be available to our respected members here, and they will also they can come back to me and of course BSI as well. Just this is the last slide. I'll take one or two more minutes. There are many enablers. In fact, when we are talking about strategy as a circular economy to adopt, as I mentioned that we need to have basically action items, and we need to understand to the extent of any industry sector or even for any organization or for any company, we need to see that what is applicable for them. And once they jotted down the various action items, there are many standards across the globe available. And I would like to mention here one of them, that is BS 8001 that came actually in 2017. And it is a framework for implementing principles of circular economy in any organization. It is applicable for any organization. And there are many other standards. I'm sure this information will be available to the respective members and they can see that. If they can come back to BSI as well. And this is just one example I wanted to share all the members. One company in Ras Al Khaimah, they are heavily practicing remanufacturing for laptops. And this I picked up from their website. And they do only remanufacturing. They don't do anything else. And based on that remanufacturing, they are claiming economic saving of 15 to 21 pound a million, and CO2 prevented 22,120 tons of carbon reduction, and resource preserved 84,000 tons. This is all on annual basis. And water saved in production 13 trillion liters, and reforestation. So this is the kind of huge benefit that we are getting it. And this is actually in practice in Ras Al Khaimah in UAE. And I want to thank you for giving your time. And if you want to download a free download copy of executive briefing is available at BSI website, which is for BS 8001, that is framework for circular economy. That's all. Thank you very much, ma'am. And if you have any question, any respected member has any question, I'll be glad to answer them. Thank you so much.
Thank you so much, Mr. Raj. This was the perfect introduction to circular economy in our day. So thank you for your informative presentation. And we hope you could stay with us for the Q&A session.
Thank you. Thank you very much.
هلأ حننتقل للمحاضرة الثانية لنهارنا يلي هي من قبل دكتور ماغاش نايدو رئيس تطوير الدائري في شركة ICLEI. وعنوان المحاضرة هي أفضل الاقتصاد الدائري أفضل الممارسات والفرص. So the second presentation for today is by Dr. Magash Naidu, the head of circular development at ICLEI, Local Governments for Sustainability. And the title of his presentation is Circular Economy, Best Practices and Opportunities. Dr. Magash, welcome. You're on mute.
Great. Good morning. Thank you
Good
for
morning.
thank you for the invitation. It's a pleasure to be here, and we've been looking forward to presenting for a few days. So I have a presentation to share. I'm just going to see if we can share this. Can you confirm that you can see my presentation in full mode?
Yes, we can.
Yes.
Fantastic. Great. Thank you. So good morning, good evening to everybody again, I guess depending on where in the world you are. The presentation I have today is structured in three main parts. The first is to tell you a little bit about what ICLEI, Local Governments for Sustainability, is about. We then go into why cities are important, particularly from a circularity perspective. And then the third part, which I guess is the main part, focuses on circular practices and some opportunities. So ICLEI, Local Governments for Sustainability, was founded in 1990, and we essentially work with 2,500 or more than 2,500 subnational governments throughout the world on the topic of sustainable urban development or management. We're currently active in more than 125 countries and have about 600 experts that are, again, located in the 24 offices that we have throughout the world. This is just a graphical representation of where our offices are located. I am based at the World Secretariat, so in Bonn, Germany. Essentially, ICLEI's strategy is guided by 5 thematic pathways, and these pathways should not be considered as being standalone or siloed. They're very much interconnected and integrated. And these 5 pathways are low emissions development, nature-based development, equitable and people-centered development, resilient development, and circular development. So lots of development taking place. And specifically, then I head up the circular development team at the World Secretariat. So that was a little bit about ICLEI, and we'll pop the URL to our websites in the chat in a little bit. So moving on to why are cities important, and we could talk about why cities are important for a long time, but I thought it best to pick on 4 particular aspects. And the first is population. So at this point in time, 56% of the global population reside in cities, and this is a huge number considering that global population is currently about 7 billion. This percentage is calculated to increase to about 66% by 2050. And this is obviously on an increased population of approximately 9 billion by 2050. From an economic point of view, we know that cities are the economic engines of our economies, and more than 90% of GDP is then generated within cities. Now, coming more to the circularity aspect of waste. At this point in time, cities are responsible for the creation of more than 2 billion tons of waste per annum. This is calculated to increase to about 3.4 billion tons by 2050, I think. So you can see we're grappling with huge quantities, and it increases the complexity astronomically. Now, just going on to emissions, naturally, if 80% of GDP is generated by cities or within cities, this is going to have a corresponding effect to emissions. So at this point in time, cities are responsible for more than 70% of greenhouse gas emissions. But what does greenhouse gas emissions have to do with circularity? It's very simple. If we're aiming to get to the point where we have net zero emissions or working towards it and trying to reduce our emissions profiles, approximately 55% can only be addressed by traditional mitigation measures. So your renewable energy, your energy efficiency, and so on and so forth. Approximately of the remaining 45%, this is best addressed by circularity interventions because it's largely due to our consumption patterns and behaviors. So in a nutshell, why cities are important. However, I would like to say it's not a competition between who is more important, whether it's business or cities or NGOs. The world's highly complex, and if we take a systemic approach to this, we find that each stakeholder has a really unique role to play. And at the same time, they need to integrate their actions to support each other because the challenges we're currently experiencing are a lot more complex and require this better integrated and coordinated interventions. So moving on to what a circular city is. This is a definition which I'm not going to read. There's too much writing there, but I will talk to it. Fundamentally, what we see a circular city is a city that promotes and advocates for the transition from linear to circular behaviors, practices in a very sort of integrated and systemic manner. And when I say integrated and systemic, I mean that there's a focus not just on city-led or mandated services, but also where cities create enabling policy environments so that businesses can implement circular business models and practices. The fundamental focus here is to maintain the value and utility of our materials for as long as possible, and keep them within the system for as long as possible. Importantly, though, we focus on three main aspects, and the first is then ensuring that there's economic benefit through the circular economy. The second is social aspects, and naturally then the third being environmental. So I'm going to skip now, and there is a QR code on this slide that will allow you to download the publication. And the publication is Circular Cities Action Framework, which ICLEI developed with Circular Economy, Metabolic, and the Ellen MacArthur Foundation. And this Circular Cities Action Framework essentially revolves around 5 R's. Now, it's important to mention that there are many R's, as you've seen in Mr. Raj's presentation earlier, and we have a variation of this as well. Our 5 R's are rethink, regenerate, reduce, reuse, and recover. So we'll now go through these 5 R's in a little bit of detail to give us a bit more structure to talk about kind of opportunities and strategies that could be pursued. So the first R, in terms of rethink, essentially sets off the journey for cities and stakeholders to better restructure and reconfigure our systems, so we can transition away from a linear environment to a more circular environment. And this is rethinking the fundamental notions that we have. For example, we have infinite resources. Not true. We need to preserve our resources to ensure that, you know, to put it bluntly, that they don't run out. Ultimately, rethink involves redeveloping our strategies, our actions, and our roadmaps to better focus on integration and the crossroads that our various stakeholders can meet. So it's not just about business and cities, it's also about rethinking how consumers consume and how their buying behavior impacts then circular economy choices. Sub-strategies within rethink, or sub-actions rather, can be, for example, eliminating linear incentives. So at this point in time, a lot of unsustainable industries receive subsidies and tax incentives from government. So perhaps it's time that these subsidies are reconsidered. But at the same time, incentives are also needed for circularity practices. So perhaps there's a need for better access to investment, preferential loans, access to better finance. And this is a very valuable element within Rethink. At this point in time, we find that businesses are very risk averse. I guess this is the current business climate we find ourselves in. And without policy certainty, there is a lack of appetite for investment. So another important aspect. We then have supporting of closed loop systems and cross-sectoral strategies. And this essentially talks about ensuring stakeholders are able to communicate. And often we find stakeholders are not communicating. Just to talk about a specific city example, we take Hammarby, which is a district within Stockholm. They've utilized, sorry, I think somebody has come off mute. They utilize a closed loop metabolism project where purified wastewater is heated using combusted household and biofuels. Once then the heat is extracted, this water is then used for some cooling applications. So you can see that fantastic efficiency was achieved just by reformulating the system slightly. The next R is regenerate, and it's a key part of circularity. And this talks to essentially two things. It talks about protecting and enhancing our ecosystems and biodiversity. And the second then is kind of regenerating the damage that's already being done due to resource extraction. Fundamentally, there are two ways that this can be done. So we talk about rejuvenating and reviving our ecosystems so that we can get better services from these ecosystems. So, for example, water purification, urban cooling, from better green cover. And then the second big aspect is kind of nature-based solutions. And nature-based solutions are where sort of your natural environment and your built environment converge to enhance life as we know it within cities. I want to just focus on a specific example here. I think we're running out of time, so I'm going to speed up a little bit. A good example is in Brasilia, which is Brazil's capital. And I think way back in 2016, they were having some D-Day challenges with their water supply. And a program with multiple stakeholders was initiated where there was a fantastic collaboration to reforest springs within the northern part of the city. And these reforested springs then were able to better supply the water bodies in the watershed within the northern parts of the city. The third R that we focus on is reduce. And reduce, as alluded to by Mr. Raj, can fundamentally mean becoming more efficient and doing more with less. And what this means from a city perspective is how do we perhaps design infrastructure in the built environment with less material, but also from a business point of view, how can products be manufactured with less material? And this does not then start at the point at the end where we're trying to reduce or where we're trying to discard materials and products and goods, but rather it starts at the design phase. So in order for us to reduce material consumption, it needs to start at the rethink phase. So what needs to happen here? Importantly, incentives need to be provided because these are really new concepts. Financial incentives need to be provided for business innovation. Incubators for startups need to be provided and facilitated by cities. But at the same time, it cannot be only cities because a lot of this knowledge actually rests within business. Also, testing labs for new materials, for new products are vitally important. At this point in time, regulations don't allow and can theoretically make illegal innovation. So compliance and ensuring safety aspects are vitally important. Another form of reduce that might not be so apparent is for cities to better link local economies together. So as opposed to transporting goods from another country, another city, linking local suppliers and manufacturers with local consumers are a good way of then reducing transport emissions. An example of reduce comes from Guelph in Canada, again with water challenges. And by leveraging of many different types of infrastructure, Guelph and Canada were able to harness or harvest, rather, rainwater to substitute the washing of buses with potable water for collected rainwater. And I believe the savings just with this one intervention runs into the millions of liters. So I will go to reuse very quickly, and towards the end, I think I need about 2 or 3 more minutes. So reuse essentially advocates for us to not buy new products. And if we buy new products, theoretically, we're then consuming new virgin materials. Reuse talks about keeping the utility value of products for as long as possible. And this can be done in a few ways. So you can either refurbish your product, you can upcycle it, and there's many different ways that this can be undertaken. A good example of this is handing down cell phones, right? So instead of throwing cell phones away once you get a new cell phone, because perhaps the performance is not good enough, you re-gift it, which is perhaps another R. An important point, though, from a city perspective is spaces. So when we talk about multi-use spaces, designing spaces that are flexible is vitally important. As we've seen with COVID, for example, lots of office spaces were left vacant. In many instances, hotels as well. And we have seen many hotels converted into a longer term accommodation. So with reuse as well, this rests a lot on the design phase. Secondhand markets play an important role here in terms of facilitating not just the ability to buy, but also the notion that secondhand is not necessarily bad. We all have the perception that buying good is new, and perhaps in some parts of the world it's very aspirational. On the flip side of this, or in addition to this, there's also the sharing part of the circular economy. So if you need the services of a car, perhaps then there's no need to buy a car, but it's just to access the service when needed. So for example, in South Korea, they focus very much as part of the integrated transport planning, a sharing system where people that do not have cars can access cars on demand. And I believe then the system is also available for bicycles. Yeah. We go then on to the last R, and very quickly, just keeping an eye to the time. The last R should be the worst case scenario, the last option that we choose. So if we've gone through the previous 4 R's and we still have material at the end of our processes of consumption or manufacturing, and then that is when we focus on recover. But at the same time, it still links back to redesign, because to effectively recover materials means that products need to be designed in a way that they could be easily separated. So, for example, many shoes that are manufactured cannot be easily separated because of the type of bonding material. Perhaps it's a way of rethinking how the materials are bound, in terms of perhaps there's a heat activated solution that could make separation of these materials a bit easier. Just again, a quick example. A good example of a recovering program at a city level is in Washington, in the USA. And this is essentially where PV manufacturers were mandated to provide a service to people who had bought PV panels and systems after June 2017 to provide a buyback system or avenue for people to discard their PV panels and infrastructure. I'm going to skip opportunities just with an eye to the time and just talk about our theory of change in 15 seconds. So we know that the circular economy is a really complex space. What we are trying to do and have been doing for the past few months is develop a new theory of change or strategy for key organizations to rally around, so that we're saying the same things in the circular space and integrating all of our stakeholders to get to a circular future. So this will be forthcoming. I want to just flight my details on screen. If you would like to contact me for further questions, that'll be fantastic. Thank you for your time, and I think I will stop there.
Thank you, Dr. Magash, for this very important presentation and for your contribution. And thank you for expanding on the 5 R's as defined by ICLEI. So now we're going to move to the third presentation of today by Engineer Dima Al-Sururi, Director of Biospheric City Lab. And her presentation is entitled Designing Under Circularity in the Arab Region, Challenges and Opportunities. المحاضرة الثالثة معنا لليوم هي من قبل المهندسة ديما السروري المديرة في شركة بايوسفيريك سيتي لاب، وعنوان المحاضرة هو التصميم في ظل نظام دائري في المنطقة العربية، التحديات والفرص. مهندسة ديما، أهلا وسهلا فيكي معنا اليوم. شكرا لحضورك.
أهلا وسهلا فيكي وشكرا للاستضافة. Thank you everyone for inviting me. My name is Dima Al-Sururi and I'm going to talk about designing under circularity in the Arab region, challenges and opportunities. First of all, I would like to know if you can all see my screen. Okay, good. So the structure of this presentation is that I'm going to first introduce who we are and what we do, and then we're going to dive into a circular economy case study, which is the Netherlands Pavilion and beyond. And then we're going to talk about the circular economy challenges and the future outlook. So who we are, our company is Biospheric City Lab. And we have a different way of looking at cities. Cities are usually looked at from a spatial perspective, but we actually look at the city from an ecosystem perspective, which relates to circularity. And I'm going to explain further how we do that. So first of all, what is the biosphere? The biosphere is a global ecosystem. It's the sum of all ecosystems composed of living organisms and non-living factors. And those coexist together and they derive energy and nutrients. So the biosphere is actually the natural closed circular system with minimal inputs and outputs. It's almost a self-regulating system that is close to equilibrium. Our ethos is that we have biospheric values, and the biospheric values are founded on connectedness with nature. We see everything in our lives connected to nature. And our mission is to create self-generating cities and developments that continue to thrive with minimum input and fully utilized output. In another way, we can say they're regenerative cities. That is our mission. And we work across multiple urban scales, from cities to urban planning to urban design, the built environment, and the sustainable development goal. I think Rajan and Magash did introduce the importance of having multiple scales and multiple sectors to work with. So what we do is that we like to experiment between all of these urban scales, and we move up and down to understand the bigger picture as well as the smaller details. And we think this is the only way we can achieve impacts in cities. So our services also vary from research to community development to spatial strategies, social strategies, circular development, and sustainability strategies and concept. We don't like to limit our work to one sector because we think it's much better to look at with a perspective that is multiple scales and multiple sectors. We also use systems thinking, which is a holistic approach to analysis that looks at the systems holistically and how they interrelate together. So instead of looking at the spatial aspect alone, we link it to social aspect, for example, we link it to multiple aspects as well. And we think this is the only way to solve compounded and entangled problems in cities. We focus on sustainable development goals and SDG 11 in particular. And I think Magash introduced why cities are very important to focus on. It's because most of the carbon emissions come from cities, even though they occupy a small percentage of the Earth. Also, to achieve impact, we like to look at the priority sectors and the sectors where the most emissions come from. And these are the energy, the agriculture, and industry. And for circular economy in particular, and for this presentation, we are focusing on agriculture and industry. Our solutions involve planning and regulatory framework for sustainable development. So we work with our clients to provide regulations, policies, and guidelines that drive circular economy and net zero strategies. And now I'm going to start with a circular economy case study that we have been working on. And it starts with the Netherlands Pavilion at Dubai Expo 2020. The Netherlands Pavilion at the Expo 2020 is an award-winning pavilion, and they had a circular economy strategy to reuse material post the Expo. And their vision was that nothing will be left behind. So basically, they were planning to leave the site exactly the way they left it without losing any material. How did they achieve that? The design was basically the part of the vision. And as Magash said, design thinking, the rethink is the first and foremost strategy for circular economy. And this is what they did here. From the beginning, they started rethinking about how we design things, and they designed everything with circularity in mind so that it gets reused. So the main structure, the walls and the roof, were created with steel sheet piles and tubes that were leased and will be reused in construction for future projects. That was designed in the thinking of the size and the length of those sheet piles within the structure. So the thinking went into the civil engineering, the structural engineering, and the architecture from the beginning to ensure that they have enough big pieces that after dismantling, it will not lose its value. If you design things with smaller pieces, it loses its value and its potential for reuse. Also, the connection of these pieces together were bolted in a way to make the disconnection so easy so that we maximize the value for reuse after the pavilion is over. The floor was also made from local sand and gravel, and synthetic mats were made with fully recyclable material with an interlocking system. So they were easily disjointed and joined together, which also ensures that they will be easily reused after the pavilion. So basically, we covered the main structure, which will be reused after the expo. They also invested in R&D and the provision of bio-based material. And the idea behind this is that even if this goes to waste, bio-based material are non-toxic, they don't have chemicals, and they won't cause any emissions post the expo. So they developed a curtain made from cornstarch that was turned into a biopolymer textile fibers. It's a renewable source that is from food. It's completely biodegradable, completely compostable, and it's a sustainable substitute for synthetic material. And we know that the textile industry is extremely wasteful and is associated with so many carbon emissions. They also developed, for the first time in the UAE, mycelium panels, and they were specially designed acoustic wall panels with a Dutch logo, and they are now used at the Consulate General of the Netherlands in Dubai. So the thinking that went behind the material is that if we use natural material that is non-toxic, no chemicals, we could reuse them, and at the end of their life, they're not harmful to our environment. So they don't have to go to landfills. Again, building on the cross-sectoral perspective, they looked at food, water, and energy all together at the same time. They didn't separate all of these. So they were designing the pavilion and they wanted to link everything that they have, every sector that they have together into one strategy. So the energy was coming from solar panels. That is a renewable source of energy. And they built a dome where they had the plants on the outside, mushrooms on the inside, and they captured water from air that came into the dome to give the right humidity for the mushrooms, and the mushrooms and plants were exchanging CO2 and nutrients. This is how they thought about linking food, water, and energy together into one holistic strategy by creating systems that support each one of them. Now, this did not end after the Expo ended. What happened is that, Expo connected like-minded people, and a business idea was born where they thought, we have built a mushroom farm and we want someone to take it over and keep the production in Dubai. So we created a collaboration with them to continue on their circular economy strategy. We bought the mushroom farm from the Netherlands Pavilion. And we're currently setting up a mushroom farm in Dubai so that we do not waste any material that was brought during the Expo. And for this partnership to happen, there was a huge amount of collaboration between different entities. First of them is the Netherlands Pavilion. And because this is a project that involves agriculture, the Dutch Foundation for Innovation in Greenhouse Horticulture that belongs to the Ministry of Agriculture was also involved. And we collaborated with Expo Mobilia on the transfer of material, the designers of the bio-based material, and the architects of the pavilion, and we were supported by the Netherlands Embassy in the UAE. So a business was born, and a circular project was born, and it's called Mycosphere, and it's a mushroom farm in Dubai. So our work with Mycosphere involves some of the R's as they were introduced by Raj and Magash. And we know that the higher in the scale, the better value you keep the material. So from the refuse, the rethink, which is the design process, to the reduce the material, to the reuse, and to the repair, this is where you capture the most value of material. The lower down the R's you go is when you're moving towards the recycling options. So we're focusing our work on the first 5 R's, which is up until the reuse and repair. So what happened post the Expo? The whole business idea started from acquiring the mushroom farm, and then after the dismantling was taking place, there were some material left over, and they said it makes sense that we also incorporate them within the same project. So we were actually given a material palette from the Netherlands Pavilion that we had to work with in our project. And that material palette was some items that relate to agriculture, some items that was building material, some bio-based material, some other items which we collected from the Netherlands Pavilion. And the challenge was, how do we work with this material? How do we put it together and integrate it into one design? That was a big challenge for someone who has design skills. Designers are creative people, and they don't like any limitations to be put on them. So for you to have a material palette inscribed on you from the beginning means that you have limitations. But we took that limitation into a challenge, and we thought it's an opportunity rather than a limitation, and we would like to reuse the material and to keep them in use as long as possible. So what we did is that we created the whole project based on reused material. Now the project is still ongoing, it's currently under construction, so we cannot share images of it yet, but we encourage you to come visit us if you're in Dubai. In a couple of months, we would love to welcome you. And the approach that we took is, instead of considering this a challenge, was a placemaking approach. We said this is a great story to have, and placemaking is about the story of the place. So we designed every element where we tell the story of how the previous element used to be in the Netherlands Pavilion and how it's actually repurposed and reused in our space. Now let's look at mushrooms as a circular element. Mushrooms are circular in nature, but are they actually circular in cities? Let's have a look. So in nature, mushrooms play a key role underground in something called the soil food web. Mushrooms break down organic matter, and they make that organic matter readily available for other microorganisms in the soil. And that gives the soil its richness and nutrition that we have. So the soil that is devoid of those nutrients will actually lead to food that is devoid of these nutrients. So the fungi plays a key role in our cities in nature. Now, when we come to cities, it can be circular, but we have to plan it and design it this way. So mushroom grows from either compost or agricultural waste. And if we actually make sure that we get this locally and from our own byproducts and agricultural byproducts, then it becomes circular. And then it becomes food or medicine, a very nutrition source, and then the spent substrates go back to the soil or can be used for creating other fuels. So they can be circular in nature. But also mycelium, which is the network, the fungal network that supports mushroom growth, is used for building material. And that is the same way that it was used in the Netherlands Pavilion. So now we can see that the food sector, by using the agricultural byproducts, can actually be linked to the agricultural sector in cities. And this is how we think cross-sectoral. And at the same time, we're thinking construction and building. So we're looking at the food sector, the industry, and the construction sector at the same time, with one byproduct in the circular economy. So there has been a few experiments where people are building from bio-based material and mycelium material, especially in the Netherlands. They are pioneers on using mycelium material, but also can go across the industry to create textiles. And there is the famous mycelium leather that is currently being produced for the fashion industry, and also the packaging industry. The packaging industry is also very wasteful, especially with all the deliveries coming to our cities. So if we can think of a renewable material for fashion, for construction, for packaging, and it's all from the same source and it's all from upcycled material, then we're looking at a circular system that crosses sectors in the city. Now, one of the challenges, the main challenges for circular economy, is material flow data. Now, we were lucky to work with someone who had a strategy in place, and they gave us a material palette. But think about all the entrepreneurs looking to implement circular economy in cities, and the fact that they don't have information about waste materials, byproducts, and they don't have access to them. And what we need to do in cities is to create that material flow, to make it available for all entrepreneurs and all companies willing to work with circular economy, so that they can find data on what material is available to use. The other big challenge is urban mining, which is how we actually deal with waste in cities. And we go to construction sites and we see everything dumped all together, with the material deteriorating, becoming of lower and lower value. And the material only becomes of high value when it's stored properly, when it's segregated properly, and when it's organized properly. That's the only way we could actually get the highest value of our material. So instead of this being waste, it becomes material that has potential to be reused in our cities. So basically, how do we turn these circular economy challenges into opportunities? The first one that we have experienced is the design limitations, and that's because we think about them as limitations. But if we think about them as opportunities, then we need a high level of creativity to reuse these materials. The second challenge is the cost due to economies of scale. Now, this is still experimental, and the examples of reusing material are still new to cities, so we don't have the right scales, and there's a huge cost due to the logistics of material. So the solution for this is to build platforms and centralized systems to help people willing to reuse material and create economies of scale. The third one is culture and stigma. There's a culture in the Arab region that waste is waste, but waste is always a resource. It is not waste. It is waste when we dump it together in a bad way. But if we actually segregate it, if we store it well, if it's super organized, then it's not waste. So the stigma is gone. We're also a culture of buying new things rather than reusing things. So we need to create awareness of the value of material and the carbon emissions saved when we keep reusing material. The logistics for transferring material is very expensive, especially for SMEs. So what we need is actually infrastructure and platforms to help people with the logistics of moving material around the city so that we could actually have larger impact in circular economy. Also, the availability of data on material is a big challenge. So, like I said, we need material flow data to be available to everyone so that they can choose and they can know what the potential of reusing material is. The quality of waste is also a big challenge. It's usually degraded and comes with a lower quality, but with proper waste segregation, we really increase the quality and the waste. And as we have seen in the Netherlands Pavilion, they thought about the material from the beginning so that they don't devalue the material. So for us, we need to think about how we design with the most value of material for reuse.
Naseema, sorry to interrupt you. We have 2 more minutes for the presentation.
I'm almost there. And that's it. I hope you enjoyed our experience with circular economy. If you like to reach to us, we are based in the Dubai Design District. Please reach to us. We are very passionate about circular economy, and we're doing a few projects with reused material. Thank you so much.
Thank you so much for this presentation and for the very interesting case studies.
Thank you.
Now we're going to move to the 4th presentation for today, which is by Mr. Riyad Bistani, the founder and CEO of EcoSquare. And the title of the presentation is Cement Sector Decarbonization Roadmap, a Case Study. المحاضرة اللي هلا نتلقاها هي من قبل السيد رياض بستاني، المؤسس والرئيس التنفيذي لشركة إيكوسكوير، وعنوان المحاضرة هو قطاع الإسمنت خارطة الطريق لإزالة الكربون دراسة الحالة. أهلا سيد رياض.
أهلا وسهلا ميرا. Can you hear me?
بشرى. Yes, I can hear you. شكرا for being with us today.
No problem. It's a pleasure to be invited to your event. I think there's a lot of things that has been said which are very common to what we do in our sector also. So let me just share first presentation. I don't know if you can see it.
Not yet.
Is it?
Yes, we can see it now.
Okay. So yes, so good morning, everyone. So basically the topic of today is following Dima's excellent presentation about how to recycle organic material. I'll talk about something which is on the opposite side, which is the non-organic material, and how the cement industry can contribute to reduction of CO2 emissions, as this is becoming a challenge for everyone. So I'll basically share with you here the brief agenda. So we'll quickly go to what we do in EcoSquare. We'll have a quick look at what the cement industry is. Probably some of you are not very familiar, so we'll go to the fundamental of how we manufacture cement. And then directly we'll go to the key point of alternatives that we use instead of fuel or raw material that can help reduce the CO2 emission, and what are the principles to make sure that this kind of implementation is successful. And at the very end, we'll look at some other options on how to reduce emissions in the cement industry, which are more on the innovation side. Some of them are already in place, but the one that I will talk immediately about is the one that is very common to a lot of cement industries. So quickly on EcoSquare, we are a company established in 2021, last year in Dubai. What we try to do is try to make sure that people understand that it's not because we have sustainability targets and a roadmap that we cannot make money out of it. So there is a connection between the ecology and the economy, and that's what we try to pass as a message. We are a number of experienced engineers around the world who have worked in many areas such as waste and wastewater treatment, alternative energies, waste-to-energy plants. And we provide different levels of, from strategic level to operation level services to different kind of clients, whether government side or private sector. So very quickly on the strategy side, which is the service we provide to some of the private sectors, it's about roadmaps and sustainability reports. It's about ESG assessment and rating, carbon assessment and accounting, sometimes leading to carbon credit registry. And on the operation side, it's more about how to design a plant where we have a source of material which is available for a client, and he wants to turn it into some valuable elements, such as some of the things we will see in a few minutes, and of course all the feasibility studies around this. So let's go directly to the topic of cement. I just picked a few articles from the press recently, and this is going on for years and months now, and it's accelerating. There's a lot of focus on how to decarbonize cement. Well, obviously because it's one of the highest, producer of CO2. Roughly, we have figures between 6, 7, 8% of carbon emissions around the world from the cement industry. And in the region, there's a lot of focus on it. So we've seen some actions from the UAE Ministry of Environment, MOCCA, who has launched a year and a half ago a facility to produce what we call RDF, and I'll come to it later on. And also in Saudi, there's a lot of course of focus, even from KAUST, who has been also launching some discussions. And so we see there's a trend of looking for solutions in the cement because we're going to be building, because there's a lot of infrastructure coming up. And we heard about all those mega projects in the region, especially in Saudi. So definitely we need to also work in parallel to solutions to reduce the CO2 footprint. So very briefly on cement process, just for those who are not very familiar, we have here a kind of a schematic of the process itself. So basically what we need in cement is on the left side, you see a quarry. So basically we need material, raw material, which compose of different elements. And these are the key elements to produce the cement. So calcium, aluminum, iron, and silica. So wherever we can find such elements, and we'll come to it in the waste material, then it's a good product to be replacing the natural resources which are found in the quarries. And then once we have the material, well, we have to burn everything. Think about the cement as a big oven pizza. So you need combustible and you need raw material, and then you can produce the cement after that. So traditional fuels, as you probably may know, are coal and a little bit of gas, HFO in Saudi mainly, a little bit of petcoke also. So these are fuels that can also be replaced by other types of fuels. And then once we have all this, then we can produce the cement, which will then later on lead to the production of concrete, which is used widely in the world to produce infrastructures and buildings, and not the type of construction like Dima was mentioning. The pavilion is probably the opposite of this kind of solutions. Just as a reminder, just to have a number in mind, the CO2 emissions from the cement industry is roughly between 600, 700, depending on the type of cement plant, the type of fuel they use, the type of performance they have. So roughly 600 kilograms of ton of cement produced. And the whole idea, and which we'll look into it now, is basically to replace either the basic material, which we see on the left side, or the traditional fuels by alternatives, which we call AFR, which is the alternative fuels and raw material. So that's the basic idea, which somehow leads to hitting two birds with one stone, because we will reduce the emission from not burning fossil fuels, so we will burn non-fossil fuels, and we will also divert the waste from landfill, which is a large producer of CO2 through methane emissions. So that's the way also the cement industry can contribute. So the next slides will focus on the AFR, which is a widely solution used by many cement players, and this is the topic of today's presentation. So as we probably saw already, I think from the previous presentations, this is like the waste management hierarchy, which probably you all know. And I just want to put what we call the co-processing, which is basically the use of such alternative, which we mentioned before, and we'll come to define what are these alternative materials later on in the slides. What we call the co-processing, which is basically recovering part of the energy or the properties of those materials within the manufacturing cement industry. So that's where we set the co-processing. So we're not at the bottom, which is the landfilling. We're not at the top, where we have basically, of course, a need for material, but we're in the end of the recovery stage of the waste management hierarchy. Just key elements. I think this is important to have in mind also, again, before we go into the definition, what are these fuels and raw material alternatives. There is a key element here, which is the respect of the waste hierarchy. We are not using waste material which can be recycled in other industries. So the purpose of co-processing is really to get rid of the material which we call the residue, or sometimes the ultimate residues that cannot be valued in the normal or in the standard waste recycling, like plastics and which are not contaminated, and wood and other type of metals and so on. So we are really looking into finding a solution to the material which cannot be reused in such flows. There's also a clear mandate to the co-processing platforms, which is to make sure that we follow all the regulations, because we don't want to create any side problem by using those waste, and we need to be sure that we are following all the international or local regulations and monitor all the flows of waste throughout the system. We want also to reduce the impact on environment, obviously, and it goes from the transportation of this waste to the storage of the waste and to the usage of it through a clear and precise monitoring of the emissions, of the hazards that you will have on transportation, on the way you store those materials, so that there's no spillage or leakage, because sometimes you have to store it outside the plant. So you want to make sure that everything is done in a proper way. There's a lot of also focus on the operation and quality of those of the process. We need to be sure that the people who are handling this are trained, because it requires specific training, that the plant is certified also. We have all the necessary permits from the local authorities that we are renewing usually on yearly basis, that we select the proper waste, because we will see later on not all the waste, but the great majority of waste can be used in the cement industry. And we also need, of course, that at the end of the process, the end product, which is the cement, has kept all its properties and quality for the building or infrastructure needs. Being also a hazardous job, focus on health and safety is obvious, on the environment, as I said before, but also on the people who are managing this. So there's a lot of focus on those. We try also, when we develop such a flow of recycling the waste, is to make sure that the environmental or the environment around the plants are informed, and that we have a transparent discussions and information with those who are working around or living around. And sometimes we even include them, and we'll maybe touch about one or two examples in the process of providing the waste. And obviously, the last but not the least is we make sure that this is a business model which works, which makes profit. Otherwise, the cement plant will not be able to work on it. And we, as I said before, sometimes the communities are involved, so we need to be sure that we have a fair distribution of the values to all the surrounding stakeholders. So briefly again on why we need AFR and why we talk about AFR in the cement industry, which is again not something new, but it has been used widely for decades in Europe mainly. It's coming more and more in Africa and Middle East where we are. There's obviously a lot of waste, especially in the Middle East area. Growing population, young, who has a consumption rate which is higher than in Europe, for instance. The collection and disposal solution are not always ideal, and there's still a lot of landfills around which are used. So this is the base of the source. And on the other side, you have a high demand of construction. We've seen Dubai growing in the last 20 years. We see the new projects coming up. And because of a lot of competition going on, we need also to reduce the cost, because at the end, the AFR solution will bring also some savings, as we will see. So that's how we get to AFR. It also addresses some of those SDGs which are mentioned here, which are all connected to resources efficiency and waste management. So going back to what I was saying, definition of some AFR, so the alternative fuel and raw materials. Just here some examples, so you can try to illustrate a little bit what we talk about. We can use tires, either whole tires or tire chips that we can shred from landfill. This is what we have been doing, for instance, in UAE. The project that I was mentioning before from the Mukka, from Ministry of Environment, was related to production of RDF, which is the one that you see here, which is basically the non-organic that you find in the municipal waste. You also have, obviously in the region, a lot of oil and gas companies. So there's a lot of what we call oil sludge, oil-related waste from paintings also that can be used because it's pasty, it's liquid, and it's very harmful sometimes. So these are also elements that can be used in the process, and also some solvents coming from the chemical industry. Again, just to illustrate some more types of AFR. Some of them are hazardous, by the way, and some are non-hazardous. So that's one of the advantages of the cement industry, is because we are using a huge quantity of either raw material or fuels, then we can basically dilute a little bit of those hazardous elements and heavy metals, which are anyway found in all these, even in the natural resources. But because the consumption is big, at the end, the emissions and the product, the content of those elements in the final product, which is cement and then concrete, are following the standards of the normal, I would say, production of cement without using waste. So this is something that is important to understand. It's not because we are using waste that we are increasing emission, because I hear sometimes a lot of people saying, "Oh, you're burning tires and you're burning, oil sludge, so probably the emissions are higher." But in fact, they are not. There are also some materials which very few of them are which we cannot use. Some are obvious, like explosive and some of this asbestos. But just to let you know that not everything, but a large majority of waste can be used. The electronics, for instance, cannot obviously be integrated in the manufacturing process. So just to, again, illustrate how this AFR are used. So this is basically a schematic of a kiln, what we call a kiln, which is the oven in the cement in the cement line. So basically materials are coming from the right side here, the raw material, which are heated up with the temperature. And you can either inject it in what we call the calciner or the kiln inlet, or we can inject it in what we call the burner, which is the flame, which burns everything at 1,400 degrees, the flame being usually around 2,000 degrees. So the whole chemical reactions within the kiln is helping destruction of all the hazardous material and making sure it integrates into the mineralization at the end of what we call the clinker, which is the byproduct of cement. And why cement players are interested? Because a lot of those materials which I mentioned before, they have what we call a calorific value, which is somehow replacing the traditional fuel we mentioned, like coal and HFO. So we see here just an example of those which I probably mentioned, like the tires, the plastics, the RDF. They have a calorific value which is high enough to replace the coal. Coal is around, well, depending on the quality of type of coal, probably between 24 to 29 gigajoule per ton. So we can see that a large majority of those materials have a substantial calorific value, and they contribute to the replacement of these combustibles. One element when we develop stories about which is now called the circular economy, it's obvious that we're trying to recycle the waste, not send it back to the landfill, and make sure we get all the potential value either on the, as I said, properties or on the calorific value side. There are three elements which usually are challenges, and which I'm mentioning here, which I call the 3 C's. First is the collaboration. There's a lot of hurdles between the private sectors and local authorities, and we've been facing this when I was back in the cement industry, because there is this fear about emission, there is this fear about transportation and storage and risk for the environment. So we need to work very, very closely with the local authorities. There's also a sense of education, I would say, with the producer or the generators of waste. So it can be large industry, it can be the owner of the landfill, which are usually the municipalities, and we need to be sure that they understand the solutions we provide, and we bring them on the site and we explain to them how we can manage it in a safe and environmentally friendly way. And sometimes there's also, which is very new, is a collaboration and partnership between industry, which usually are not connected, because they bring solutions to a large industry like the heavy industry of cement. And we've seen a lot of startups working on carbon capture, working on recycling plastic, for instance, in the oil and gas. So this is also something which develops a lot in this kind of recycling and circular economy. The second point, which I think is very key for me, is the change of mindset. And being an engineer myself, I see that it's probably one of the toughest barrier that we face when we try to make the change, because usually engineers, they want to work in the old ways and without having extra complications. So we need to explain to them, we need to train them, as I said before, to the new type of solutions that can help our environment. This comes also with a top management buy-in that has to be there from the company, who has to think not on the short term, which usually is the business model that we have today, but rather on the midterm, because sometimes you need investments, you need CapEx, which will give you a return, not on the first few years, but maybe on the 5 or 7 years horizon. And obviously all this is making sure that employees are also part of the change, because we have we have implications from all levels of the cement plants, and that they see that what they are doing has a purpose, which is, I think, something that is coming more and more in the surveys that we see around. The last and also important point is obviously everything has to be cost effective. Otherwise, cement players will not go into this. So again, it's not going to be a short term, it might be a midterm, but then there's going to be a benefit. Obviously, using waste like RDF will cost less and will be more sustainable, because unfortunately we will have waste for a long period of time. So once the process is in place and we increase volumes and we inject more and more in the cement plants, then the benefit will be there, and we will not be fluctuating with the price of energy as we have seen lately, how energy prices and costs have been skyrocketing. So this is also another advantage of using the waste. And one of the way also to drive this and put incentive is to increase the landfill gates, which are probably one of the first starting point to make sure that the waste can be traveling from Emirates to Emirates and also be reaching the cement plants at a reasonable cost. So this is it for what I call AFR, and obviously I'm happy to answer any question later on once we have the Q&A sessions. I just wanted to focus on some other options which are also there, which are probably less common and maybe less visible from the public side. So here are some examples. We have the waste heat recovery, which is basically, as you've seen in the previous picture, there's a lot of energy and heat that is used to burn all this material. So that energy can be reused somehow in the process. So it requires a little bit of capex also, but this is one way also to reuse the heat that otherwise would be dissipated in the environment. There's a lot of things that our cement players usually work on, which is the product portfolio and trying to reduce somehow the content of clinker, which needs combustions, and using what we call the cementitious, which are put after the combustion. So by increasing this level, then we are basically, putting a cement with a higher content of cementitious rather than clinker. One of the examples is, which has been also in the news, probably, I don't know if you're familiar with cement, is the calcined clay, which is one of the innovative solutions which requires less combustion. We've been talking a lot about construction and demolition waste lately for the concrete side, so it's not on the cement side, but it's one of the largest in the world in terms of volume and weight, obviously, because it's massive. And this is starting to become standard in Europe. I was just, in fact, this week, just got back this morning from Switzerland, and we see a lot of companies using construction and demolition waste by crushing all this material, segregating what cannot be used like steel, but the rest of it can be used as aggregate. And we have also a plant, I think in Fujairah now, which is also recycling construction waste and producing aggregate. And I think the regulation is somehow allowing to use 40% of recycled aggregate in the industry. Carbon capture has been also a topic in many industry and includes also the cement industry. And it's one of the solutions that cement players are working in. We've seen also, again, this week, there was a very interesting company, a startup, trying to put the carbon within this recycled demolition waste so that the CO2 can be basically reincorporated in the mineralization of the material, the raw material, and then used again in the construction phase. And of course, there are many options to work on CO2, but I just wanted to give you a highlight of the major one, which was the AFR, so the alternative fuel and raw material, which is widely used in cement industry, and some of the options that some key cement players are working on. And I'm sure there will be more development in coming years on those. So this is the end of my presentation. Obviously, I think there's a Q&A session later on, so I'm happy to answer any question. Thank you.
Thank you so much, Mr. Riyad. In fact, the Q&A session is now. So I think we can start taking questions. There was actually one question for you. So the question is it possible to use sewage sludge as AFR in cement industry?
Okay, very good question. And in fact, the company I was meeting yesterday is using sewage sludge. The problem with sewage sludge is that the calorific value is not as high as the other alternative fuel, but it can work in countries like Switzerland where they have high gate fees. So it's all about because they have a policy of producer payer. So whoever is producing waste has to pay, and usually they pay a high amount, which is not the case in our region and UAE, in Saudi, for instance. So it could be used, but again, it's about who's going to be paying part of it. But on the process side, it's basically the same as the other. So the same injection points can be used for the cement and use it as a fuel in that case for sewage sludge. So the answer is yes.
Thank you. I think that there was one more question. Is that compared to conventional construction process, how much cement can be saved in 3D cement printing? If you have any idea.
I'm not sure I can answer this question. I'm not so much related to 3D printing, but I know that they have been doing a lot of trials and they've been building some houses with it, so it's working. But I'm not really sure about the ratio. I can check if the person can send me an email. I can have a look at it.
Okay. They're also requesting that you share you're gonna share the presentation.
Yes,
with us
I can.
later. Yeah, so we're gonna share them on our website and social media. So you should have the contact details. And if you could please, Mr. Riyad, maybe write them on the chat box just for the attendees today. I would like to ask the attendees who have any more questions to let us know. I had a question to Ms. Dima Suri, if you're still with us.
Yes, I am.
So my question is, what's the impact of this? We're designing for circularity and to leave nothing behind, but what's the impact of that on the time and cost of a project?
On the time of the project, first of all, it's in the design phase, and it's usually the design is the more time we give the design, the better the outcome is, anyways. So it's the benefit is not just for the circularity, but for the design as well. It becomes more meaningful. But time is equal to cost as well. The more time we spend, the more cost we spend. But if we compare that to the emissions that we have saved, I think we should spend that time for the environment. It's much more worth it.
It's very impressive, the case study. So, but the thing is, how practical is it? And of course, like if it comes to a private entity, it needs to be somehow more practical in terms of time and cost. But I think this could be developed as as you said, with the economies of scale, it would help a lot.
Yes, I think there was commitment from the design team in this particular case, and commitment from the entity where the handover happened, which is in case myself. So for that to happen, you need that commitment. Otherwise, everyone would say, business as usual, we design the way we design always. Why should we care about the material, right? It's not my problem. I'm a designer. That's the scope that I'm doing. But they took that pledge upon themselves, and they took the pledge to find partners to work with them. And it was a learning curve, and I don't think it was perfect by any means, but I think it's a great start for us to learn from in the Middle East.
Of course. Thank you, Ms. Dima.
You're welcome.
Still have a couple of minutes. Mr. Raj, are you still with us?
Yes, I'm available. Thank you very much.
I also had a question for you. So when we look at the different R's related to circular economy, and when we're coming to a shift towards circular economy in any region, how do we look across industries, and how do we plan to do so, and how do we choose between the different R's? So is there any set frameworks that we can use to do so?
Thank you very much for the question. Indeed, it's a really very good question. And as I said, circular economy, it has been picking up now, and there are a lot of definitions, and of course, there are a lot of variations as well. But overall, as I mentioned, that we are talking about basically cradle to cradle kind of metabolism in the whole industry sector. So if we see for one industry that we are trying to manufacture certain things and then we are selling it as a product, When we look at from the circularity point of view, then not only that, I need to look at within my company or within my kind of a boundary or my kind of supply chain. I can look outward as well and look at that how I can integrate my supply chain material, even waste item. Certain waste item, instead of reusing myself, it might impact my product adversely, and the same byproduct can go to my neighbor company, and it can impact much better from the environmental point of view. So what I mean that we need to look at creatively at various stages of production, and then we need to see the different concepts of business model as well, like remanufacturing or designing for the disassembly, such kind of things. When we go into details, then it will make our whole production system and the consumption pattern towards a circular economy. Now, to achieve this, how do we do this? So there are many documents, guidance, standards which are available, how they can enable us to do such kind of activity, which we are talking as a kind of philosophically. Then when we go into that detail, there is one standard that has come out. It's basically a guidance document called BS 8001, and it's a guidance document on circular economy. Now it has a lot of components that talks about that how what kind of innovation we need, how we need system thinking, how we need product stewardship, and there are actually six concept pillars actually in this document it talks about, and then it subsequently talks about various kind of business model, how we can reorganize our business model. And in fact, there are certain companies, and I have witnessed them changing the now they have started looking at their business model. And fortunately, because of this COVID time, in addition of course drive from the circular economy, we were forced also to think innovatively. And as I shared on my screen, there is a one company in Ras Al Khaimah. They remanufacture only laptop. They don't have any fresh resource or fresh material. They are taking it and they are selling it, and clients and customers are extremely happy, and so much saving that they are doing it. So to answer your question, there are many standards and systems, practices that helps us in jotting down my action item for my sector. There are many standards and guidance available, but for my sector, my company, I need to see creatively for my kind of processes. And then we need to, once those details are available, we can sort it out in terms of how we can go forward.
Yeah. Thank you so much for your answer, Mr. Raj.
Thank you very much.
Okay, so in case of no more questions, I think we can resume with the session. The fifth presentation that we have for today is by Mr. Kanak Gokkarn, the Junior Officer in Sustainability Energy at ICLEI, Local Governments for Sustainability. And his presentation is entitled Supporting Local Governments with the Energy Transition.
Yes, hello. Can you hear me?
Yes.
So Miss Kanak, sorry.
Miss Kanak, sorry.
No problem. Let me just turn on my camera and share my screen. Okay.
Yes, I can see you.
Great. Give me one
I'm just
second.
gonna translate it in Arabic.
Hmm?
I'm just gonna translate it in Arabic.
Okay, please.
المحاضرة هلا هي من قبل السيدة كانا غوكارن تعمل في الطاقة المستدامة في شركة إيكلي، وعنوان المحاضرة هو دعم الحكومة المحلية في تحول الطاقة. Ms. Kanak, thank you so much for being with us today.
Okay, great. Thank you for having me, and I'm glad to be here speaking on ICLEI and its work in supporting local governments with the energy transition. Just briefly about ICLEI, we're a network of 2,500 local and regional governments spread out globally, and we're committed to sustainable urban development. Most of our work carries across these 5 pathways. I will be talking mostly about our low emissions development pathway, which is where our energy work is situated. But as you can imagine, these pathways are interlinked and our work cuts across them a lot. This is just a brief snapshot of our global presence. You can see we have many member countries as well as networking countries who we work with quite closely, cities, sorry. And this is our presence. So we have a number of regional offices that carry on the day-to-day work. And me specifically, I'm located at the World Secretariat in Bonn, and we sort of provide a global perspective and are present at international fora and so on. So just to lay out the challenge that we face, I assume most of you are already familiar with these, in that, you know, a global GHG levels have reached record highs and show no signs of slowing down. Cities are, of course, huge engines of the economy and therefore responsible for a very high share of global energy demand and therefore their associated emissions. Most of the world seems to live in urban areas, and that number is only set to grow based on various projections. But paradoxically, almost 1 billion people lack access to reliable energy, as well as, you know, clean cooking services and so on. And much of the energy that we use is lost on the way due to, you know, technical losses and just inefficiencies in use and so on. So hence the need for urgent action in this space, because energy is really at the core of the climate crisis, and any action on energy will be a part of the solution. So just to give you a background of how ICLEI sees sustainable energy and energy action, is that we believe sustainable energy involves meeting our present needs without compromising the ability of future generations to meet theirs, which is in line with sustainable development in general. And most of our focus is on renewable sources of energy and the enablers that can help speed up this transition. And of course, we're aware that energy intersects with a number of other attributes. So we would push for this energy to be deployed in a socially sensitive, nature-conscious way based on the local context. We released this statement a few months ago. You can find it on our website. But as you can see, I mean, energy is really at the core of a number of international and national initiatives that we have. Obviously, transitioning to a system that's less reliant on fossil fuels and more reliant on renewable sources of energy with their low emissions and other benefits is critical. And this has to be, of course, matched with energy efficiency and conservation efforts. I mean, renewable energy itself brings with it a number of other benefits, such as improving resilience and adaptation efforts, especially for, you know, traditionally underserved communities. The energy is cleaner, and it can help improve energy security, which is, of course, a critical issue these days, by reducing reliance on sort of volatile markets, let's say. But yeah, it is a cornerstone of any climate action. Snapshot of how we work, because as a network, our job is to amplify the voices of our members at various fora. So we work at different levels. At the international level, for example, we would be involved in advocacy and messaging and trying to gather support for our cause. At the national level, we would advocate for our members with their national governments, try and promote greater linkages, since that multi-level governance aspect is also critical. And then, of course, at the local level, we cater to our members. We help build networks on specific topics. We help facilitate peer exchanges, and then we provide technical assistance across a number of cross-cutting themes. This is an overview of some of our global projects that take place across a number of countries. We have a number of initiatives to support as well. And we believe that, of course, the local context, the local spaces where much of the action happens, local governments are on the front line for, you know, leading their communities through any big changes, and especially a change as big as the renewable energy transition. And although at a national, international level, we get lost in the abstract, but it is really at the local level where you start facing the challenges, and these challenges are very context specific. So local governments have a better idea of what their communities are going through, and they can better advocate for that and develop solutions that work for everyone. I mean, whether it's through, just planning or integrating energy and climate action into other development plans or mandating energy efficiency and conservation, or even just setting examples through their own assets and so on. And for this, of course, they cannot do it alone. They don't exist in a vacuum. So cooperation with other levels of government, especially at the regional and national levels, is also critical. So they need the frameworks to enable them to act. I would like to proceed just to move from the abstract into more specific examples of some of the work that we have done at a local level. For example, in Rwanda, in the city of Kigali and the Muhanga district, under the Urban LEDs project, we were able to install solar water geysers and solar streetlights to help sort of strengthen the functioning of their local healthcare centers. As you can imagine, hot water is a critical input. So this was a way to help address that while also keeping in mind the climate mitigation angle. Similarly, in Bangladesh, under the RECAP project, we helped the installation or facilitated the installation of water ATMs that are powered by solar energy that provide clean drinking water, and once again address a critical development need while also minimizing the impact on the climate. Some of our more involved work is through the 100% Renewable Cities and Regions Roadmap project, where we work with local governments in Argentina, Kenya, and Indonesia, and particularly 3 deep dive cities or regions in all of them. And this is more of a strategic governance oriented project. So we help them start planning out their pathway towards reaching 100% renewable energy. So you can see the process laid out here. We form the teams, we help them with data collection, conduct a number of consultations to see where the need lies, what their priorities are, and so on. And we provide them with the technical input to be able to develop their strategies, to be able to reach this quite ambitious goal. And then we help them with the capacities to develop projects and really start implementing the strategies that they have. And it's quite interesting because each of these 3 cities have very different governance structures, very different contexts, priorities, and so on. So it's interesting to see how different their pathways could be. And this is where the value is, right? To see how local action can contribute to a national, global level target. This is just briefly our definition of 100% renewable energy. I mean, often it's conflated with 100% renewable electricity, but for us, we use the definition from the IRENA Coalition for Action, which means all energy end-use needs, so including heating and for transportation. So it goes a bit beyond just the power sector. Beyond that, beyond the 9 cities in the project, we also have a broader network of cities engaged in renewable energy action, and I'll quickly present to you some of the examples just to highlight the benefits of having networks like this, seeing what sort of innovative solutions are going on in them and how others can learn. For example, the city of Orlando in the US, they have a 100% renewable energy target, and their sort of innovative solution was photovoltaics, where they build floating solar PV on water bodies, which of course has cross-cutting benefits with land use and so on. Cost of the system might be a bit higher, but again, these are good examples to see what's possible. Similarly, Vancouver also has a 100% renewable energy target. Given that much of their electricity is already carbon-free, there's a big hydro potential there. Their big focus has been on buildings and transportation. So they have a quite robust policy on zero emissions buildings new buildings by 2030, and it includes plans for retrofitting the existing stock and so on. And they clearly lay out the policy approach that they take to try and incentivize industry and homeowners to make these changes. Malmö in Sweden, again, they also have a 100% renewable energy target, and their big contribution is using waste to energy as a stepping stone to 100% renewable energy use, which again brings some of the principles of circularity in here to try and create a sustainable energy system in the city. And finally, we have Palmas in Brazil that aim to encourage the installation of solar rooftop PV through tax incentives and by developing policies that can facilitate it. Some of our other projects, global projects, include the SESA project, the Smart Energy Solutions for Africa project, which takes place in 9 African countries. And here the focus is on implementation and scaling up local solutions. They do this through local living labs where these solutions are co-developed and meant to be replicated and validated throughout the other cities. This is just a highlight of the technologies that they're talking about in this project. And finally, I maybe neglected to mention this yet, but financing these local energy transitions is a critical barrier, and it's one of the challenges we hear the most about. So this project, the Benin Energy Plus project, was meant to help address this need in terms of building local capacities to be able to identify and really capitalize on the various financing mechanisms that are available. In this case, it focuses on public-private partnerships for renewable energy. In Benin's context, the law was passed quite recently, so it's still a new space to be explored. So the idea is to provide governments with training and tools to be able to understand the process and what goes in there, and to hopefully capitalize on this to start implementing whatever projects they want to do. So yeah, I'd just like to maybe conclude on that and reiterate some of the messages that have come through from our work, which is that we really do need urgent action, and at the local level, bringing on board the various stakeholders that are present. Because in the energy transition, it's not just a technical supply issue, but it's also one that involves people and the way they consume energy and so on. And that obviously has ripple effects into other areas of life as well. Second, I would say channeling the appropriate resources to where they're needed the most is urgent, particularly finance. And there's a number of challenges there as well, but ICLEI, for example, we have a transformative actions program that tries to address these needs, help get projects up to a point where they're able to access this finance. And third, of course, this is common knowledge that the transition to renewable energy with energy efficiency and conservation measures is going to be critical, and we cannot stop on this. It has to be, we have to act even faster than we have been. And we've seen many small scale interventions, which of course address immediate needs, but obviously the change is also needed at a more systemic level. And here we would stress the need for multi-level governance to be able to see what works, scale it up, and really transform the way we consume energy and so on. So that brings me to the end. I hope I'm within time. Thank you for your attention. And here are some of our contact details. Feel free to shoot us a message. I know many of my colleagues will be at COP this year at the LGMA Pavilion, so please feel free to stop by if you will be there. But yeah, thank you.
Thank you so much, Ms. Kanak, for this very nice presentation. I hope you will still be with us during the Q&A session. Okay.
Yep, I look forward to it. Okay, thank you.
Thank you. So now we're going to move to another presentation by Ms. Jessica Obaid, founder and CEO of New Energy Consult. The presentation is entitled Energy Storage and Supply in the Arab Region, Enablers and Barriers. المحاضرة هلأ هي من قبل السيدة جيسيكا عبيد، المؤسس والرئيس التنفيذي لشركة نيو انرجي كونسلت، وعنوان المحاضرة هو تخزين الطاقة وإمداداتها في المنطقة العربية، العوامل التمكينية والعوائق. Ms. Jessica, hello, how are you? You're on
Hello.
mute. Hi.
Thank you for having me.
Thank you so much for being here.
It's my pleasure. Let me share my screen. Again, I seem to be having a technical problem.
We can see it now.
Okay, so is my presentation working?
Yeah, it is.
Great, so I'm going to go through why energy storage in MENA countries is important, what drivers we have, the opportunities, but of course, like all emerging technologies, we have several challenges. First, let me start by the power sector trends. We see that the key problematic and the key challenge we have in the power sector in the region is that we have an unsustainable rise in power demand. So when we look into electricity consumption, we see that this is driving a race to additional power generation, which is unsustainable as a long-term strategy. The demand growth rate is on average annually increases by 7 to 8%. And this is mostly thermal generation, consuming a large share of fossil fuels. The annual growth of installed generation capacity in the region averages 7 to 10%, compared to a global rate of 6% for thermal generation. We also expect that the future is going to drive more electricity consumption. So the future is electric, which is driven by rising temperature, impact of climate change, increase of population, economic growth, but also electrification and digitization of sectors. Despite that this is the general outlook of the region, we also see that many countries still face growing power supply shortages, chronic and lengthy power outages. The race to add power generation is increasingly accounting for renewable energy deployment, and we see that renewable energy investments in the region are on the rise. Achieving energy diversification, of course, in this region that's heavily dominated by fossil fuels and is energy intensive is going to be a complex task. But the deployment of renewable energy has been gaining traction, despite, of course, that the pace and rate across the different countries varies. The total installed capacity of non-hydropower renewable energy in MENA, which is mostly wind, solar, and some bioenergy, has almost reached 12 gigawatt in 2021, up from 10.6 in 2020, but this is more than the double of the installed capacity we have in 2010. When we account for hydropower, the installed capacity exceeds 20 gigawatt. That's based on 2021 figures. We also find that many countries have very ambitious renewable energy targets. In Saudi Arabia, we have the highest target, which is 50% of electricity generation from renewable energy by 2030. The lowest would be in Iraq and in Kuwait, 15% of electricity generation by 2030. Most of the countries have interim target for 2025 or 2022. Although at the current stages, most countries are at less than 2% renewable energy targets. That doesn't apply for Jordan, which is almost at 20%, and Morocco, which is almost at 36%. So where we are now is still at a very slow pace, but we see that we have very ambitious targets moving forward, and 2030 is in almost a few years. So we really need to ramp up this capacity very fast. But this is going to be easier said than done. Integrating variable renewable energy is complex, especially for the grid and the power systems. So this requires grid expansion, connectivity, energy storage, among other flexibility systems. When we look into grid expansions, this is of course at the core of a successful energy transition, which requires expanding, upgrading, and modernizing the grid. But grid expansions and modernization are not fast enough. And this is around the globe, not only in the region. But MENA countries are beset with a set of challenges facing the integration of this renewable energy into the grid. We have high level of curtailment, low flexibility, limited capacity, non-reliability and losses, and even in so many countries, low access in rural areas and underinvestments. In terms of connecting the grid and grid intercons, we do have in MENA 3 different grid intercons. They're still not connected between each other. Grid interconnections are supposed to enable a smoother integration of renewable energy, enhance energy security, grid stability and flexibility, and enable us to have an efficient electricity exchange market in the region. However, in the current business as usual scenario, how we're using the grid interconnections in the region, we're mostly using it as a diversion mechanism for power outages, to ensure continuous supply across connected countries. So all these grid interconnections are operating at a very low rate. The GCCIA Gulf Interconnection Authority is operating at less than 5%. So we have all this huge potential of connecting the grid, but working on this is also going to take several years until we have an efficient electricity market. And then we get to the importance of storing energy. The higher share of variable renewable energy in the power mix means we're going to have higher variabilities and prospects for imbalances in supply and demand when we're adding all these shares, all these projects and farms of solar and wind. Meeting the national renewable energy targets is going to require a lot of deployment of energy storage systems, especially that we're focused so far on solar and wind and their variabilities. So energy storage systems can manage the intermittency of solar and wind and their impact on the grid. Now, so why do we need all these energy storage systems? They allow us to mitigate the challenges of integrating variable renewable energy and manage the need for curtailment and also the need for fast ramp up in power generation sources when the sun sets or when wind is not available. One of the functions of energy storage systems is to ensure that electricity is available for dispatch. As we know, solar and wind are not fully dispatchable electricity. They are there when the weather permits, when the sun is shining, when the wind is blowing, but we need electricity normally when the demand is there. So energy storage systems enable us to have this electricity available for dispatch whenever we need it. There's also multitude of grid services that energy storage systems can perform, a few dozens of services that the grid needs. The most lucrative currently being in the markets that are currently ahead in the deployment of energy storage systems are capacity firming, frequency regulation, energy arbitrage, among the other services, but these are the most lucrative. And I'll go through later why this is important currently, what kinds of lucrative services we have and why it matters. Also, energy storage systems enable us to defer the necessary upgrades for a transmission and distribution network, which would allow us to delay further additional investments into grid until the future. Historically, our power systems have been very simple. They focus on balancing supply and demand through continuous increase on power generation. The new power systems and the new technologies make these systems quite complex, but also make the reduction of peak demand a key focus. This service, energy storage system, can also provide as peak shaving. And this is also why energy storage provides a lot of services that the market needs. And this should be a key requirement for Middle Eastern power markets. As I've mentioned earlier, we have a very unsustainable growth in peak demand. And we see that now, even in markets that have sufficient reserve margins, we do have in months like July and August, where they're reaching the new highs in peak demand because of high temperatures. Sometimes we're seeing blackouts. This has happened in Kuwait and others. Also, energy storage systems would help us rectify the duck curve when we have all the solar energy being pumped into the grid and suddenly, not suddenly, well, the sun sets every day. When the sun sets and suddenly we lose all this storage, all this electricity generation. We have different type of energy storage systems. The most common we're hearing these days are, of course, the electrochemicals such as batteries, lithium ion, sodium sulfur, and others. We have chemical energy storage such as hydrogen and ammonia, thermal such as molten salt, mechanical systems which are some of the oldest and most deployed systems in the world, such as pumped hydro and compressed air, and electrical such as supercapacitors. So what's driving this market, emerging market of energy storage systems in MENA? The different types of energy storage systems that I've mentioned here in the previous slide, and what kind of applications and services we need are, of course, based on each site requirements and the grid requirements, what the power market is, what the regulations are, and the potential revenues. And I'll go next into the revenues and the cost benefits assessment of this energy storage system. So there is no one case that fits all. And the drivers, of course, are going to vary across the different countries in the region. Jordan, Egypt, Morocco, and Gulf states, among others, are motivated by ambitious renewable energy targets and their action plans to get there. So this translates mostly to utility scale, front-of-the-meter applications where energy storage systems are placed and at the utility level, at the utility scale level. So front of the meters are, as the word is, not on the consumer side in front of it. Behind the meter is on the consumer on premise on site behind a consumer's meter. So these are grid scale energy storage that are going to be required to be connected to generation in terms of collocation, maybe of wind and solar, wind with energy storage, mostly batteries or others, or on the transmission and distribution network. So this could be deployed via renewable energy plus storage auctions as well, so we can have renewable energy, solar plus batteries auctions. Currently, these front-of-the-meter applications are 89% of all the energy storage systems installed capacity in the region. However, for countries that suffer frequent power blackouts, that have chronic electricity shortages, such as Iraq and Lebanon, we see a more deployment of behind-the-meter, smaller energy storage systems at the consumer's premises. So this is going to be the next big market. MENA region has already deployed 1.46 gigawatt of on-grid energy storage systems application. That's compared to 10 gigawatt by the baseline of 2020 for these figures, which is the global rate. Pumped hydro storage holds the largest share of installed capacity in MENA with 55%. It also has a global share of 90% still, because chronically this is what we used to implement. This installed capacity in MENA comes from only 2 projects which are in Morocco. Thermal storage, molten salt, which is mostly implemented with CSPs in the region and constitutes 29% of the share. Batteries are only at 7% of the operational capacity these days, because they have a smaller size than the pumped hydro and molten salt, but they constitute 80% of the total projects. Batteries are, however, gaining traction globally and also in the MENA region. The largest share of battery capacity currently installed is in the UAE and is of sodium sulfur type. Sodium sulfur has been selected and has, because it has advantages over lithium ion, especially in terms of the lithium ion sensitivity to temperature, and because sodium sulfur has been able to provide higher duration of storage compared to the 2 hours of lithium. But there are many challenges. So we know there's a huge opportunity. We need these systems. There are so many drivers. There are so many opportunities, so many services that the grid and the region requires. But there are so many challenges to overcome as well. On the regulatory front, most countries, not all MENA countries, require definitions and regulations for energy storage system. And this is very important as we move forward from vertically integrated to unbundled utilities, and in the future, more liberal markets. So it's very important to define what is actually the energy storage assets and which entity can operate these assets. Is it the utility, the operator? Is it on the generation side? If in some countries we've seen that they will have defined energy storage systems as part of the generation, which has made it difficult then for private sector or developers to implement storage on the transmission side or on the distribution side. So making this comprehensive and also issuing targets, just like we have in renewable energy, is going to be needed to drive the energy storage systems market forward. Some of the existing regulations are quite important to drive smaller scale renewable energy, such as net metering, but in their application that they could hinder the deployment of energy storage. So some of the ways is we need net metering, of course, we want to provide an incentive for renewable energy, but some of the ways is to provide that 75%, for example, of the installed renewable energy capacity or the generation on premise can be injected on the grid, whereas the remaining 25% could not be. Then it would drive consumer, especially when we talk about commercial and industrial consumers, to deploy energy storage behind the meter. On the financial side, energy storage system is quite complex in its cash flow. It's not the same as renewable energy, where we just sign power purchase agreements and we know that we're getting a stable, constant revenue over several years. In the case of energy storage, we're selling the storage capacity, but we're also, the capacity alone would not make a project bankable. So we need to sell services, what's globally known as stacking revenues through these services. So we see if the grid is going, if the grid operators, for example, require frequency regulation, this could be, there could be a specific cost for this frequency regulation or other services, capacity firming, that the grid operator, there could be regulations on how much the cost of this would be. And the developer of the energy storage system is going to be compensated not only for the capacity of storage, but these services. But these services are deployed whenever the grid needs that. They're normally not also, so the battery is going to have a lifetime, for example, for 10 years. So, and the grid services are probably, grid operator is not going to sign an agreement to buy services for 10 years, but probably a lot less than this. In some markets, it's like 4 years. So you need to stack these revenues. You know that your cash flow is quite variable. It's not constant. It has variable factors based on this stacked revenues, and the risk is very high. This is why financing energy storage systems globally is still very complex, and we need to find all these incentives to make it bankable. So we have the stacked revenues model, which creates a challenge, and the complex cash flow. We have an additional challenge in the region, which is normally the underinvestment in all things like the grid, especially. So we do have some investments mostly go in the power sector for generation, but we also have in the transmission and distribution network a very lower share, insignificant share of investments. And that's in the market that have ability to attract investments. Of course, we have the economic instability and political instability in many countries that also add challenges to attracting investments. We have the high financing, I just still need 1 minute. High financing costs in many markets and the lack of incentives. Energy subsidies, like in all low carbon technologies, it just hinders all deployment of low carbon technologies, renewables, but also energy storage systems. The power market design, by design, since we're all utilities are predominantly state-owned and mostly vertically integrated and dominated by a single buyer model, it means that the government kind of needs to pay for additional technologies, and mostly, especially when electricity is subsidized, cannot pass it through to consumer. Renewable energy auctions that have prioritized only the lowest price among technically compliant offer would need to be rethought if we're going to integrate renewable energy plus storage, because of the particularity of energy storage systems and the different revenues and the different services that need to be accounted for. Thank you.
Thank you so much, Ms. Jessica, for this very informative presentation on energy storage systems.
Thank you. It's my pleasure. Thank you for having me.
Thank you for being with us today. Now we're going to move to our last presentation for today by Mr. Alan Chow, New Power Director in Africa and the Middle East at Cummins. And his title, the title of his presentation is The Landscape of Hydrogen in the Arab Region. المحاضرة الأخيرة لليوم هي من قبل السيد ألان تشاو مدير الطاقة الجديدة في أفريقيا والشرق الأوسط في شركة كومنز. والعنوان المحاضرة هو معالم الهيدروجين في المنطقة العربية. Mr. Alan, hi. Welcome and thank you for being with us today. You're on mute.
Okay.
Yeah,
Can
we
you hear me okay now?
Yes, we can. Thank you
All
for
right.
being with us today.
Okay, thank you. Thanks for everybody joining. Thanks for the opportunity to share some thoughts and information here. Okay, so are we ready to go then?
Yes, the floor is yours. If you would want to share your screen.
Yes, I will share my screen. And with this, can you all see my screen?
Yes, we can.
Okay, great. So thanks everybody. Yeah, just maybe very quick. First of all, the topic today is on the hydrogen landscape in this region. I am Alan Zhao. I work for Cummins. I lead the new power and in this way, really hydrogen and fuel cell for the Africa Middle East region. That basically covers all the Africa and Middle East region, where basically we cover some around 60 some countries in the way we classify for the business. So today I want to maybe just go on to talk a little bit about, first of all, just for today's discussion, I wanted to just really talk really quick about Cummins New Power, just so you know what we do, and then really looking at hydrogen demand, and then looking at the production and its use from at this point of time, as well as where we go from here, and the challenges and the potential solution paths. And so this is kind of the high-level agenda or content that I'm going to cover today in this next set of 20 minutes or so. Okay. So first of all, really quick talk about Cummins New Power in Africa Middle East region. First of all, very quick high level. People may not really know Cummins. Cummins actually is a global company that we're 100+ years old. We have $24 billion revenue, and we actually have been in hydrogen business for over 70 years, and we're investing globally roughly $1.1 billion in research and development. We have our presence in 190 countries, and we have 8,000 distributors and dealers and over 60,000 employees. And in that, we have 5 business segments for the company: the engine business and power systems and components distribution. And the last but not the least is New Power, which is where we talk about fuel cells and hydrogen. And also on the right-hand side, right corner, you can see a little bit about where our, let's see here. So, okay, you can see this is where high level our U-Power capability journey, and really started back in 1948 through acquisition of some of the businesses we've been acquiring since 2017 timeframe, 2014, we started to acquire more businesses in the new power side of things. So I don't need to go into all the details about that journey, but the key point is that we have been with this, we have been in this new power business for a long time on the hydrogen and fuel cell side of the business. Okay. Next is just to do a really quick kind of high level. If you look at our traditional business, you look at, we are traditionally an engine or internal combustion engine, and leverage that engine technology for power generation. That interface working with the grid provide emergency power as a backup, or continuous power to provide the power for consumers. And with that engine, internal combustion engine, we drive many different applications that it's critical to economy. And so semi trucks and delivery, and then in the mining trucks and buses, and or even the train, and many different services. Okay. Now, moving forward, once we add the new power capability in, you will see how our portfolio with this. When we talk about new power, we're actually talking about zero emission technology, where we're really invested in the battery electric for the powertrains, and fuel cell for both powertrain and stationary power, as well as the electrolyzer for hydrogen generation and hydrogen storage to enable the hydrogen being used for fuel cell in the vehicle, as well as the stationary power, and also using for hybrid type of powertrain applications. Okay, so that's the high level technology. And if you look at overall now growing our complementary set of technology to enable the applications of the new technology or zero emission technology. And what you see here is significant growth in what we are able to enable the rest of the energy transition through our existing and the future technology. So in this way, we are enable the current applications through our internal combustion engine, as well as providing in transition technology such as hydrogen internal combustion engines and zero emission technology, as we just talked about with fuel cells and hydrogen generation, storage, and working in partner with renewable energy suppliers, solar, power producer, wind, and also partner with our partners to enable ammonia production through our hydrogen generation technology. So as you can see that now we really are support our customers in that energy transition with their existing and future applications. So since today it's mostly about the hydrogen generation topic, I also wanted to share really very high level our product offering for the product, where we actually look at the electrolyzer technology that we offer, are really looking at the size of the project from small to medium to large to extra large and extra large. Based on the size of the project or customer demand, we have a different level of product and the technology. So less than 1 megawatt of input power required for electrolyzer, we offer our alkaline technology, and beyond 1 megawatt, we offer our PEM-based electrolyzer, and grow the size to scale up all the way up to a gigawatt level of project. We actually do for the PEM technology, the largest PEM electrolyzer have been installed, 20 megawatt have been running for 3 years in Cummins in our technology. This is the largest installation for PEM technology have been running for 3 years. I think this is the largest in the world today in operation. So this is a kind of our technology, and also really quickly our footprint on the how big we are. Also, even for New Power, we are globally located. So just so you know that we're not just in one location, we're globally having global capabilities supporting our customer globally on the New Power zero emission technology. And so here, just highlight, show you different applications with our technology being actually deployed. So the point of this slide is not, it's really just say that some of those people, we have actual applications for those technology, not just simply a concept level. We actually have actual installation, actual applications running. For example, like recently, there will probably be have been a lot of discussion about Alstom train in Germany. That is powered by Cummins fuel cell, and the number line we talk about the world largest PEM electrolyzer in operation, and various other applications as you can see here. So those are just a really quick highlight. Just say there is some reality to it, and it's not purely theory. And here you can find more information about our product. So that's really about, so far it's all about our capability, what we're doing as a company. But I wanted to really start talk about the hydrogen production in this region. So getting into that topic and to really look at, based on the work that we've done as a company and also the global environment situation. So first of all, looking at the hydrogen from hydrogen and production perspective and the demand. First, looking at the demand. So this comes from International Energy Agency, and looking at the growth of the hydrogen demand, right? You look at right now, 2020, there is a roughly over 100 million tons of hydrogen being produced. So with this, first of all, basically this also saying that hydrogen production is not new. The means in which it will be produced in the future will be new, will be different. But the hydrogen production itself is not new. Hydrogen in actual usage is not new. How we use it, how we produce it will be new. So the other important point here is that you can see that there is a significant growth projected, right? Roughly 5 times more by 2050, and roughly 2 times more by 2030. But this demand projected this level of demand, but where are the key off-taker partners for this region specifically, right? So I think it's really important to think about not only the production, but really think about who will be taking those hydrogen and could put it for good use, right? So Europe has definitely been identified as one of the top off-taker. Japan, Korea have also been identified, and the agreement between with European countries and such as Germany, France, and UK, have been signing a lot of agreement. Japan, Korea have signed a lot of agreement in this region. REPower EU initiative have also identified the import of 10 million tons of hydrogen per year by 2030. So those are clear demand for the hydrogen in million tons. And so this level of growth, how do we actually be able to produce it? I think we wanted to really look at how it's being produced today, looking at how it could be produced in the future, and what's the differences. I think it's really important to understand that transition, not only from the growth perspective, but the means or the ways in which that the production will change. So first of all, as we already talked about, 2020 is roughly 151 million tons of hydrogen being produced. And by 2050, it's roughly 510 million tons that's being projected. But if you look at how this graph also showing it's from IEA again as well, looking at, first of all, looking at the source, basically on the left-hand side, looking at how it's produced, and also look at how it's being used today for 2020. And if you look at that, saying today or 2020, the production predominantly are driven from natural gas, right? Over 40%, 196 million tons out of the 200 from natural gas, and then there's a coal production, and then there is oil, and from the oil, and then other byproduct. So this is how it's being produced today. How that's being from all those sources, how that's being used, if you look at today, is actually being used in, first of all, in oil refinery, 39 million tons out of 151 million, and the 31 ton roughly is the same for ammonia, right? That's those, and then very, very small amount for transportation and others. Those are the pure hydrogen usage and demand. The other set of the usage is what you call a mixed hydrogen mixed with other gases for things like methanol production and in direct iron reduction, also relatively small, and the others. So as you can see, that those are the current usage. Now, how is it going to change by 2050 is expected that the way it's going to be produced, as you can see here, is going to be more than half are expected to be produced through a technology, electrolysis technology, meaning it will be mostly driven from splitting the water to produce rather than from things like natural gas and coal, driven primarily by the reducing of the carbon footprint. And also then expected that roughly 40% of them may come from similarly like the natural gas or coal today, but we'll have to add the carbon capture technology to reduce that carbon impact. And the usage of it, right? This increase in the usage or demand are primarily be driven from the sectors that's hard or expensive to directly electrify, things like steel production and shipping and the fertilizer. So as you can see, even in this, that dramatic increase in demand are really actually not talking about the consumer-based hot topic. It may still be relatively small, but significant growth in the hydrogen generation or demand come from those hard to electrify segments. So I think it's kind of important to understand that how we envision this to be used and what actually maybe the hot market is saying. A lot of discussion about transportation was so on and so forth, but it's important to kind of think about that, how this dynamic is. And the other way, really think about, so if we think about all of those production, then we say, okay, why this region, right? Why would this region being positioned well for that production and, you know, in this transition? There are two, as we actually previously talked about in these slides, talk about two primary sources in the future. One is through electrolysis. The other is through current means, but it's through carbon capture technology. So what's the advantage for this region to be able to do that? So there is an inherited cost advantage for this region for hydrogen production. First of all, you know, a lot of discussion today talk about green hydrogen production. And if you look at what's the fundamental, one of the key driver, right, for green hydrogen production is renewable energy. From the renewable energy perspective, and this region, as you see on this map, possess the most, you know, concentrated in the world, most concentrated renewable energy that enable the green hydrogen production that will produce at most competitive rate, except like if you look at Chile, maybe slightly lower, and maybe pretty much, you know, there it's, you know, the lowest. Maybe Australia slightly better for some region, but generally, you know, you see very competitive. So that's a very important competitive advantage. If you look at the through carbon capture, that, you know, primarily driven from natural gas reserve. So this region also, you know, have unfair advantage, if you would use it that way, say that there's a significant amount of natural gas reserve in this region to enable even the blue hydrogen production. That is also the cost advantage and the reserve advantage. So if you put this together, then you can see how this region be able to capture or be one of the key enabler for the hydrogen generation or enable the transition. So this region really have that inherited cost advantage, and as a key enabler for, you know, the world energy transition or hydrogen economy. Okay. The other thing I think a lot of people talking about this, you know, today talking about how important is the technology development and future improvement will enable the competitive hydrogen production. This graph done by, you know, Roland Burgers, done really interesting study in their hydrogen transportation industry report, looking at the cost of electricity versus the cost of the hydrogen in the vertical, and comparing with the existing gray hydrogen production, blue, and green hydrogen production with different technology maturity level. What this is showing is if some region have electricity rate in the less than 2 cents per kilowatt hour range, you could already be able to produce hydrogen that's competitive with the gray hydrogen today, which is this line, right? So what this shows is how we actually build the renewable electricity, or be able to have the cost-effective renewable electricity is one of the key determinant factor on whether the hydrogen produced or green hydrogen produced would be competitive with the traditional method or not. So obviously technology will play a role in here, pretty very important role, but it's more also more critically think about the actual electricity cost may even play a bigger role. For example, if we say the electricity rate is at say 5 cents, right? Even with the future technology, it's still not competitive with today's green hydrogen. Doesn't matter what technology improvement may be, even up to 2050. You know, the 2050 technology improvement. So that's actually pretty important to think about. You know, pretty important to think about and realize the important role different aspects play in this journey. So what the other thing we see here is really from recreate on this region's huge initiative and really increase the renewable electricity availability and capacity, realizing how important renewable electricity would play in the hydrogen economy transition. And here you see significant initiative from from the countries in this region to ramp up the renewable energy capacity to enable the green hydrogen production that could take place to enable the hydrogen economy, green hydrogen economy going forward. And so this is, as you can see, this tie all together really, really nicely. So this region really have its advantage, and people are, this region are taking strong initiative to enable the world, make it happen, to move forward. But with all those great potentials, what are the challenges to actually get there? Here are the, at the very high level, here are the, different level of challenges, the legal and regulatory framework challenges, and evolving economics and technical commercial barriers, and the financing constraints. So now, different people will have probably prioritized those challenges in a different order. My personal perspective is, in this region, because we are really a lot of the countries in this region are really thinking about, or the initiatives are more aimed towards exporting because it's inherited cost advantage. Then I think actually legal and the regulatory framework is potentially a bigger issue than other factors. So for example, if we wanted to export green hydrogen or green ammonia, how do we actually even certify the grain as green? If there is not a agreed legal and regulatory framework, then that marketplace may not be in place to enable that. So I know there are a lot of discussion. Most people today would say technical and commercial barrier is probably a bigger issue. I would argue differently. For this region, I think a legal and regulatory framework is a potentially bigger issue. And even to the point, we talked about how cost of electricity is one of the key enabler or determining factor on the hydrogen production cost. Today, electricity and water are utility. Even within each country, how we regulate those utilities, how do we enable the actual hydrogen production itself is a major issue. If we can resolve that, then that hydrogen production is also being hampered. Therefore, for this region, I think it's a much bigger issue. However, if the production of hydrogen is really only for more domestic use, where it's really truly just reducing carbon footprint, that country can deal with that regulatory issue more easily than trying to resolve those regulatory issues at international level. That's the point I say, depends on how it's being viewed, and then your priority may change. So when we talk about evolving economics, I have a slide later when you talk about this. We already talked about techno-commercial barrier, which is effective with this slide to talk about how techno-economical things intertwine together, depends on how technology evolve, depends on the cost of electricity, and all of those kind of will determine your cost structure of the hydrogen being produced. So, but these two, the B and C, or evolving economics and techno-commercial things, are intertwined. Many times people talk about this as a chicken-egg problem. Or is it a chicken-egg problem? But I think if we have A, B, and C resolved, or have a way to resolve that, then I think financing constraint can be resolved. Now, financing constraint in this case could also be, the potentially, many of those projects are being financed by today's revenue stream. For example, in this region, financed by our the current oil and gas revenue, and so on and so forth. If economy were to take a turn, how would that continue? That's a question I think people will need to think about. But in general, I think it's a less of issue potentially, because there are a lot of funds available today where does wanting to move forward on on the zero emission, on net zero, or carbon neutral going forward, right?
Mr. Alain?
Yes.
We have a minute or two.
Okay. Yeah, I can wrap up in 2 minutes.
Thank you.
So yeah, thanks. Yeah, so this is really looking at the evolving economics and really trying to compare various different ways of producing. As you can see, gray hydrogen today costs through the steaming, reforming, is anywhere from less than $1 to $2 range. As you can see, by 2050 or so, you can see that the green hydrogen could potentially get there. So because of this, current production versus the cost versus 2050, we will always have this competing factor of which one do I go. I think in this case, I think there is a way to move forward and think about, which is my next slide to say, really we can. That chicken egg problem could be solved by really focusing mostly on the economically viable solutions as an early adopter, for example, like ammonia production or using hydrogen for steel making and so on and so forth, right? To really have that early adoption to build scale so that we can bring the technology breakthrough and reduce the cost for mass production so that we can get to 2050. We don't have to stay in this never-ending chicken egg. And if we can focus on small amount of applications, but still large enough scale to bring technology breakthrough and reduce the cost in that process. So that really is my overall, presentation and information sharing with you.
Thank you so much, Mr. Alain. It was very informative.
Okay, thank you.
Thank you.
Thanks for the opportunity. Yeah.
We're going to move now to the Q&A session. So I would like to ask from anyone who has a question for one of the speakers to please type them in the chat box. I do have a question for Ms. Kanak, if you're still with us.
Yes, hi.
Hi, Ms. Kanak. So you talked about policy development in for cleaner energy in different regions, and you said how different regions would have different requirements, and how you see the region and its current conditions before going off in the policy development. So so what's the process that you use? What are the first things you look at?
I would say, I mean, given the way we work, it would depend very much on the aim of the project and also the needs of the local government. I mean, obviously, we're not telling them what to do, but we try and see what their priorities are and how that situates in the broader national context. And we would provide recommendations, help them come up with plans, whether it's climate action plans or energy specific plans. So I can't give. It's a dialogue essentially, like with any policy making, and we try and bring in learnings from other similar experiences, earlier projects or so on. So I hope that answers it briefly.
Thank you, Ms. Kana. Mr. Allen, I think there was a question.
Okay.
About the graph.
Okay.
So someone said they couldn't understand the USD per kilowatt values. Could you please explain what the cost indicate?
Could clarify which graph and then cost, because I think I have like 2, 3.
The last one, I think the one with the gray hydrogen.
Okay, so let me go back to that. I think this is the one we're talking about.
I think the one before it.
Okay.
Slide 16.
Slide 16.
Yeah.
This one?
Yes.
Okay. So what this graph is trying to show is the x-axis horizontally is the cost of electricity. And the vertical graph shows the technical cost of hydrogen produced with various technology and with different efficiency level. So for example, let me go to this, sorry. I'm trying to get pointer on. Okay, so let's point. So you can see, so first of all, these 3 bars here talk about gray hydrogen cost, blue hydrogen, and green hydrogen. So if we're looking at that green hydrogen production cost, this is a green hydrogen production cost with 3 different technology level and cost level. So this, the highest one is the cost of, or the cost of the electrolyzer with a 75% efficiency. The next line is 2030 technology at the cost of the $434 per kilowatt at a 77% efficiency. And the last one is talk about $200 per kilowatt, as you can see, cost reduction dramatically, and also efficiency improvement quite a bit, 82%. So by looking at your electricity cost, along with the different technology curve, you could get a rough estimate of your hydrogen production cost. Compare that with today's hydrogen production cost. That's how this graph could be read.
Thank you, Mr. Alam. There's another question asking about the difference between the different hydrogen.
Different hydrogen, okay. So let's go back. So First of all, at a very high level, traditional method of saying gray hydrogen is made traditionally. Let me show you by this graph. So the feedstock for making hydrogen, for making gray hydrogen, are carbon-based, such as natural gas, coal, and oil. That would be classified as gray hydrogen. The other end of the spectrum is called green hydrogen. The green hydrogen does not have carbon as a feedstock. Also, the power that used to produce the hydrogen is also green, meaning renewable. Does not have power come from carbon supported, meaning the power source is not coal-fired plant, for example, right? So that would be the green hydrogen. Then there is this, now come back down to this called blue. So what is the blue hydrogen? Blue hydrogen is basically a gray hydrogen with carbon capture technology, meaning in the process of making gray hydrogen, there is a carbon emission. Then there is a carbon capture technology to capture those carbon emission and store them or reuse them. But it's not being emitted in the air. That is called blue hydrogen. Now, if you look on the internet, there are other things like pink and other colors. The world does not have an internationally agreed definition of exactly what that is, but generally you think about varying degree of carbon emission would define different level of emission and or use of carbon in producing hydrogen will determine different color of the hydrogen. But I think for this purpose, just think about these three things will be, I think it's good to think about gray and green and the blue.
Thank you, Mr.
Hope that's
Allen.
helpful. Yeah.
There's a follow-up question from Muhammad, but I didn't understand the question, Muhammad. If you can remove the mute and ask the question directly. The question was, but why the production cost is compared in kilowatt terms? Why not quantitatively? The question is referring again to the graph.
Hi, Ellen. I'm referring to that graph. You know, the thing I don't understand is you're comparing the cost US dollar per kilowatt. Are you comparing it after the conversion in the electricity format, and how? I mean, this is I can understand. You know, it should be quantitatively in terms of metric tons or whatever the quantity is there. By the way, I'm from Caterpillar team.
Okay. All right. Thanks, my friend. So, okay, let me, Mohammed, and let me answer your question. So it's a really good question. First of all, compare cost of the electrolyzer using dollar per kilowatt is the existing industry norm, meaning if you were to buy an electrolyzer, and the simplest way of comparing the cost between the electrolyzer manufacturers is using how much do you pay per kilowatt of input power. There is a general correlation, not direct one-to-one, general correlation on the kilowatt of power input to kilogram of hydrogen. But that is, how does that convert is based on the efficiency being talked about here. You know, if you are 75% efficient, so 75% of the 1 kilowatt get converted to be equivalent of kilogram of hydrogen in the thermal term thing, there is a conversion. But generally, that's how it is. To your point on that, I personally do not agree with using this metrics as a way to measure the improvement, because as you can see here, the efficiency become important factor as well. So simply using dollar per kilowatt without considering efficiency is misleading.
Yeah, that's true. Thank you again, Mr. Allen.
Yeah.
Do we have any more questions to any of the speakers? I don't think we have any more questions. So I'd like to thank our speakers again for the very, very helpful presentations and for your time. And I would like to thank again our participants today. And hopefully tomorrow will be the last day of the Arab Sustainability and Environment Week, and it will be equally beneficial. The theme for tomorrow's session is creativity and innovation in energy technologies. So I hope you all can join us again tomorrow for the last day. بحب أتشكر كتير المتحدثين معنا اليوم والحضور على وقتكم، وإن شاء الله تكونوا كتير استفدتوا من النهار. بكرة إن شاء الله الموضوع الندوة حيكون الإبداع والابتكار في تكنولوجيا الطاقة. شكرا للجميع. Thank you so much, Mr. Allen, and for all the speakers. So see you again, hopefully tomorrow.
Thank you.
Have
Thanks,
a nice
everybody.
day.
Bye.
Bye.